Hi everybody and welcome to Econometrics Lecture 4. Today we are going to talk about panel data regression. And you can find more about this in Chapter 10 in Stock & Watson. But as always, read the book and watch the videos. So let's get to it. This topic is best explained by use of an example. So our example is traffic deaths and bear taxes in the US. A lot of states, they change the bear taxes to combat traffic deaths because traffic deaths are often caused by drunk driving. So our task here is to investigate whether bear taxes, our X, is designed to discourage traffic deaths, which is our Y variable. And this is a causal effect we are investigating, which means that we are focusing on the beta on beer taxes, right? So we would like for our beta to be as close to and a best guess, an unbiased guess of the true beta, right? So we could form the simple regression model of y equals beta naught, the intercept, plus the slope times beer taxes. But in this regression term, the u, we would have a lot of emitted variable bias, probably, because we only have one x variable trying to explain the traffic deaths. So what do we have? We have panel data for 48 states over 7 years. A bit old data, but it's okay. And we have the x variable, and we have the y variable. Bit sloppy there. We have data on the y variable and on the x variable, the beer tax. So what would this data look like? How would it be organized? Well, we would have our entity here and our timestamp here, and we would have one column with the y variable and one column with the x variable. And what's special with this data is that one observation is the observation of y and x for one specific entity and one specific time. So we use subscript I for the entity, and we use subscript t for the time, which means that our y and our x variable, they need two subscripts, one for the entity and one for the timestamp. And quite important, if we have a balanced panel, then we know that we have data for all combinations of entity and time in our data. We have no missing data. And if we have a balanced panel, then we have a total of n times t, the number of time periods times the number of entities, number of data observations on y and x. And this means that entity, we have the counter I, and I goes from 1 to n, which is the number of entities, and time we just denote by t, and t goes from 1 to a capital T, which is the number of time periods. Because in sorry, in panel data, you see that we have data for each entity over several time periods, and we have data for several years for the same year over several entities, right? And this means that y, to pinpoint which y value you point at, you need to have both the entity and the time in the subscript, and the same for x. And one example could be this: the x value for Alabama and 1982. So if you say that, well, give me the x value for Alabama in 1982, then you know this is the number 1.539. So, and why do we care about panel data? We actually care about panel data because we can expand our model, our simple regression model, to account for variation over time and variation over entities. And this enables us to capture the omitted variables, which either are constant over time or constant over entities. So this is why we would investigate panel data. So see you next time.